see here is a game that I'm currently making by myself in UnrealEngine. It's a trick shooter and it takes a lot of inspiration from games like Titanfall, Mirror's Edge and Roller Drome. When it comes to making an FPS, one of the most important things, as you might have guessed, is that shooting is fun. And that is a surprisingly complicated thing to achieve when making a game, not only from a technical perspective, but also from a design perspective. In this video, we'll take a look at how I've studied other FPS games to figure out exactly what is needed to make the shooting fun for the player. And I'll show you how I've set it up in my project and how I handle my workflows. I'm Carl Cadium, and most things that you see here was modeled by me in Blender, and I've set up most of the gameplay logic using C++. This video is part of a DevLog series for these games that I currently call Liquid Lungs. In a recent video, I covered the basics and explained how my game's movement mechanics work. If you're curious, definitely check it out. If you're enjoying this series and want to see more, please consider subscribing. Don't forget to hit the like button too, it really helps with the YouTube algorithm. Thank you for your support. Oh, and I will probably also release a public test version somewhat soon, so don't miss that. So far, this game features things like fancy parkour movement, slow motion aiming, and reloading by sliding. I also have these ridiculous AI goons that are pretty fun to just run around and shoot right now. So let's take a closer look at the shooting. This is what it looks like shooting into the wall. There's a lot to unpack here, so let's break it down. The weapon and arm moves, the camera moves, there's a bunch of Niagara particle effects when hitting the wall, like emitting dust and sparks, as well as a smoky trace line. We're also leaving bullet holes in the wall, and the aim cursor size is updated. There's also some cool weapon sounds and a muzzle flash. Let's remove all the particle effects and see what it looks like. Yeah, looking pretty dull right now. The shooting uses ray traces to check if something has been hit or not, which means that we are basically drawing a line forward from the weapon's muzzle to see if something has gotten hit. So there is never any physical bullet being shot. Using an actual projectile is also a good approach, and it's how I plan to handle the enemy weapons in the future to make bullet dodging a thing. If we were to also remove the weapon and arm animations, as well as the camera movement, it would be hard to tell that we are shooting at all, except for the decreasing ammo count. The complexity in FPS shooting mechanics isn't always immediately apparent when you're just playing a game. That's why I've spent a lot of time studying the shooting in games like Titanfall, Apex, Unreal Tournament and even Counter-Strike. Analyzing these games helps me pinpoint what makes their shooting mechanics fun. It helps me understand how to fine-tune my game to achieve similar standards. I modeled the guns in Blender and created the materials for them in Substance Painter. It's been really fun to learn hard surface modeling, and although I still have a lot to learn, I'm very happy with the progress of my Blender skills. When comparing my early weapon models to the new ones, I watched countless of tutorials and modeled a bunch of random items to practice. After I finished modeling them, I used the Smart UV Project function in Blender to automatically generate the UV map. To use this, go to the UV tab, select all the vertices you want to project in edit mode, then press F3 and search for Smart UV Project. I was recommended to set the island margin to around 0.03 somewhere, and that seems to work well in most cases. I don't create the materials in Blender, but I do assign the material slots in Blender. These slots will be used after exporting the model to Substance Painter. After exporting and importing the model into Substance Painter, I let Substance Painter auto-generate all the needed texture maps, like the normal and metallic maps. After this, I can simply start assigning materials and tweak them to the model's material slots that I assigned earlier. All weapons share the same C++ class, but they each use unique datasheets that contains all the specific information about that weapon. The datasheet is defined in C++, and we can then inherit from it and access it in the UI. Here we can control everything from the particle systems used at certain times to the damage and number of bullets for each weapon. The player has a weapon management component that handles which weapon is currently equipped, what weapons are currently in the inventory, and switching between the weapons. I've sculpted the arms in Blender, and learning this took a long time. I find sculpting process to be much more difficult than hard surface modeling. It also involved a lot of trial and error to figure out a good workflow from sculpting the arms, creating the materials for them in Substance Painter, and integrating them into Unreal. In 3D modeling, you have points called vertices, which are connected by lines called edges and the filled space within them. is called a face. When you create a 3D model for a game, you need to reduce the number of vertices for performance reasons. Take a look at this cube. It has about 8 vertices. When I finished sculpting the arms, they had over 200,000 vertices. Many indie developers prefer to go with low poly for their entire game. It's fast to create, offers good performance, it's easy to manage, and it can look absolutely amazing. But I like problems, apparently. The way I handle this is to first create a retopology version of the high poly model. However, this version will have lost a lot of detail. We can then bake the details from the high poly model, the one with many vertices, onto the low poly model. This allows me to retain the high detail, but with some loss, of the high poly model, but with only the vertices of the low poly model. This is possible because the model's details are now stored in texture maps, like normal maps. I thought this was absolutely incredible when I realized that this is a thing that can be done. This video will be too long if I show my procedure here, so I'll have a separate video on this in the future, so make sure to subscribe so you don't miss it. The arm and weapon animations are super important to make the weapon handling look good. All player animations are procedural. This allows me to perfectly blend them between states, and I don't have to recreate them for every weapon. The player arms are set up in an animation blueprint and leverages inverse kinematics, which basically makes the arm bend correctly when moving the hand's position. They do have a weapon socket where the weapon is attached to when equipped. So here I actually prefer to use the animation blueprint version over the C++ for the built-in Unreal function for handling the inverse kinematics. My animation blueprint class does however inherit from a C++ class, where I do handle things like interpolate values between different states and a bunch of other things. It also allows my player class to easier communicate with the animation logic. Taking a look at the weapon skeleton mesh, we have a few different sockets, like aim socket, left hand socket, and a muzzle socket. This allows me to only slightly tweak these sockets on new weapons to get the weapon into perfect positions. There's also a bunch of other animations except for shooting and aiming. Just when standing still, we can see the weapon and arms have an idle sway animation. And when we move the camera around, the arms sway behind a bit and make it look more realistic. This is not always needed in an FPS game though, mind you. Many old school FPS games or games that take heavy inspirations from that era can look quite charming without it, but it's not the look I'm going for. For handling recoil animation, we can simply add some random positions to the weapon when shooting. These are controlled in the weapon datasheet that I showed earlier to easily be able to create and tweak different type of recoils for different weapons. And when done shooting, I simply let the weapon interpolate back into the idle position. Note that the camera is also moving and shaking when shooting to make it look more impactful. And of course we also have a sprint animation, which is just rotating the weapon a bit down in combination with some larger idle sway. As you can see, these animations are very easy to produce with this setup and they all layer together perfectly. Alright, that's it. I haven't fully decided what topic to bring up in the next video, but I'm considering discussing the enemy AI, how behavior trees work, and how I handle their models and animations. If you have any thoughts about the project or video, please leave a comment down below. This format was a bit different than my previous video. Which one do you prefer? And again, remember to hit subscribe so that you don't miss the next video, and please like this video to help grow the channel.